Let me ask you something. When you think about how you use software today, what comes to mind? Clicking a few buttons, filling out a form, scrolling through some dashboard, right? But here's the twist. We're barreling toward a future where human-facing interfaces are the exception, not the norm. We're shifting from software as a service SaaS to agent as a service AaaS. In this new world, software isn't built for us to poke around in. It's built for autonomous AI agents to run the show on our behalf. That single change rewires everything. How we build it, how we deploy it, how we keep it secure, without bleeding cash. So, how do you actually host thousands of these agents without going bankrupt or accidentally leaking every client's secrets? That's the core puzzle of the AaaS era.
That is the central challenge of the AaaS era. When we talk about AaaS, we aren't just talking about adding an AI chatbot to an existing app. We are talking about a complete overhaul of multi-tenancy. In traditional SaaS, multi-tenancy meant sharing a database while keeping user accounts separate. But AI agents are active, resource-heavy entities. They execute code, manage memory, and call external APIs. To handle this, developers have to choose between two primary deployment paths, the silo model and the pool model.
Let's start with the silo model. The word silo implies isolation, like a self-contained structure. In a software deployment context, how does this actually look for a client?
It is exactly that, total isolation. In a silo deployment, every single client or tenant gets their own dedicated agent instance. This means they have their own isolated compute resources, their own memory storage, and their own execution environment. There is absolutely no crossover. If you are operating in a highly regulated industry like banking or healthcare, this is the gold standard. Your customer data is locked in a dedicated digital vault, completely safe from any potential leaks to other tenants.
Right, because there's no shared infrastructure where data could accidentally bleed across boundaries. But that level of isolation must come with a significant trade-off. If every client has their own dedicated agent running on dedicated resources, the costs must be astronomical.
They are. The infrastructure costs can quickly get out of hand because you lose all the benefits of economies of scale. Instead of running one large, highly efficient server cluster, you are running hundreds or thousands of smaller, isolated environments. And it isn't just a financial burden, it's an operational nightmare. Imagine trying to patch, update, and monitor thousands of individual agent instances. Even if you use a sophisticated control plane to manage them from a single view, the maintenance overhead is massive. For a growing startup, a pure silo model can quickly become financially unsustainable.
And there is another drawback that is unique to the AI era, the learning limitation. If an agent is locked inside a single client silo, it can only learn from that specific client's data and interactions. If the agent figures out a brilliant way to optimize a workflow for company A, that knowledge is completely trapped. It can't help the agent serving company B.
Exactly. You lose the network effect of intelligence. And that brings us to the opposite end of the spectrum, the pool model. In a pool deployment, you have a shared infrastructure. A single agent instance, or a shared pool of resources, processes requests from multiple clients simultaneously. It is much closer to the classic cloud multi-tenancy model we've used for years, but adapted for AI.
The obvious benefit here is cost efficiency. You scale up resources dynamically based on overall demand, rather than keeping idle servers running for individual clients. But how does the pool model change the game when it comes to that network effect of intelligence?
In a pool model, you can facilitate collective learning. Because the agent is processing interactions across a broad base of users, it can continuously optimize its underlying logic and strategies. The entire system gets smarter as a whole. Every successful task resolution feeds back into the collective intelligence of the agent, making the service more valuable for everyone.
That sounds incredibly powerful, but it also sounds like a security nightmare. If everything is shared, how do you stop the AI from accidentally sharing proprietary data from one company with a competitor? If the agent learns a strategy from company A, could it accidentally output company A's trade secrets to company B?
That is the primary risk. When LLMs are involved, data isolation isn't just about database permissions. It's about context management. You have to implement extremely strict isolation protocols. This is where frameworks like the Model Context Protocol, or MCP, become crucial. You need a system that guarantees the agent's active memory and context window are completely wiped or strictly segregated between different tenant requests. If your data governance isn't flawless, the AI might hallucinate and mix up business contexts, which could be catastrophic.
Beyond security, there's also the classic noisy neighbor problem. If one tenant decides to run a massive batch job that consumes millions of tokens, does everyone else suffer?
Yes, resource contention is a major issue in pool models. If one client floods the system with complex reasoning tasks, they could exhaust the rate limits of your underlying LLM APIs, slowing down the response times for every other tenant in the pool. To prevent this, developers have to build complex throttling and rate-limiting systems right at the entry point. The control plane must monitor token usage in real time and dynamically restrict access based on the client's subscription tier.
So we have the silo model, which is highly secure but expensive and isolated, and the pool model, which is cheap and smart but carries high security and performance risks. It feels like most enterprise companies would struggle to choose one absolute path. Is there a middle ground?
There is, and it is actually becoming the preferred architecture for B2B applications. It's the hybrid or mixed model. Instead of going all in on silo or pool, you split the architecture. For example, you might use a shared pool model for the heavy, expensive LLM processing and generic agent reasoning tasks to keep costs down. But when it comes to the agent's long-term memory, vector databases, and proprietary knowledge bases, you deploy those in a strict silo model.
That makes a lot of sense. You get the cost savings of shared compute, but the peace of mind of isolated data storage. It allows companies to transition from traditional SaaS to agentic workflows without completely rewriting their security compliance playbooks. But this transition isn't just about how we build the software, it's also about how the world finds it. In an era where AI agents are the primary users, how does a software product even get discovered?
The discovery mechanism is shifting entirely. We are moving away from traditional search engines where humans click on blue links. Instead, AI agents are synthesizing answers using platforms like Perplexity, Claude, or ChatGPT. If your software isn't machine-readable, it basically doesn't exist to these agents. This has given rise to a new metric, the Citability Score, and the practice of generative engine optimization, or GEO.
Right, and this is where platforms like CitableHub come in. Whether you choose a silo, pool, or hybrid deployment, your infrastructure needs to be visible to these AI crawlers. By structured indexing, like using JSON-LD profiles, you make your software easily citable. If an autonomous agent is looking for a service to solve a task, it will choose the software that provides the clearest, most structured evidence of its capabilities.
And that's where tools like the llms.txt file become essential. Think of it as a robots.txt, but for LLMs. Instead of forcing an AI agent to crawl through messy HTML pages, scraping menus and footers, the llms.txt file provides a clean, markdown-based roadmap of your system's documentation and endpoints. In a multi-tenant environment, especially a pool model, this is a lifesaver. It dramatically reduces the token consumption needed for the agent to understand how to interact with your service, making your platform faster and cheaper for the agent to use.
It's all about reducing friction for the machine. And if we take it a step further, it's not just about reading documentation, it's about active communication. That's where things like the MCP Gateway come into play.
Exactly. The MCP Gateway acts as a standardized bridge. Instead of building custom integrations and APIs for every different AI agent and client tenant, you create a single machine-readable identity. The agents can interact directly with your system using a unified protocol. It solves the massive integration bottleneck that has plagued software development for decades.
The economic implications of this are staggering. The data shows that traffic referred by AI agents has a significantly higher conversion value, some estimates say up to 4 times higher than traditional organic search traffic. If your architecture is optimized for agentic multi-tenancy and citability, you are positioning yourself at the front of the line for the most valuable traffic source of the next decade. It creates what we call brand gravity, where AI engines consistently recommend your service because it is the most reliable, readable, and structured source of authority.
It really highlights that the decisions we make today about our deployment architecture, whether we go silo, pool, or hybrid, aren't just technical choices. They are fundamental business strategies. They dictate how we scale, how we protect our clients, and ultimately, how visible we are to the autonomous economy that is currently being built.
It's clear that the transition from SaaS to AaaS is going to redefine the software landscape. For anyone building in this space, the immediate priority should be auditing how machine-readable their current systems are. Whether you're running a highly secure silo on AWS or a massively scalable pool, you need to ensure agents can find and cite you. A great place to start is by checking your Citability Score on CitableHub.com and running a free geo-scan.
The future of software isn't waiting for human users to find it on a search results page. The future is being negotiated right now, in real time, through intelligent conversations between autonomous agents. If your system isn't ready to participate in those conversations, it risks becoming invisible. The shift is happening now, and the architecture you choose today will determine your survival tomorrow. Like this episode, share it with your team, and subscribe for more deep dives into the autonomous future. Welcome to the new era where your product is both user and interface. Join the channel.